Alright, 4.1 notes. We're going live here, so if you hear me yelling at a kid, it's my 7th block. I'm going to call them out by name, make fun of them. Everybody, for the years on out, they're going to know who you are. Alright, so in this section, most of this is review. A lot of these words we did in chapter 1. So basically, classifying, there's two ways to classify triangles. One by their angles, and two by their side lengths. So I kind of think of this as like your first name and your last name, so you have two names. When you look at angles, do you guys remember what the word acute meant? How small? Less than 90 degrees. So if all three angles are less than 90 degrees, you are called an acute triangle. Alright? Now, if one of the angles is 90, you're called a right triangle. If one angle is greater than 90, remember obtuse meant greater than 90 degrees. If one angle is greater than 90, you're called an obtuse triangle. And then if all three are equal, you're called equiangular. Alright, equal angles. So, that's your first name. Your first name is based on your angles. Your second name is based on your sides. This is kind of a funky word here, but when you have no equal sides, no tick marks anywhere, so for instance, maybe you are like 5, 7, and 8, alright? No sides are the same, you're called scalene. So a scalene triangle, that's probably a new word. Scalene triangle has no equal sides. You're just some old mutt triangle with no special properties. Isosceles, scratch out at least. Some textbook get into, is it exactly, is it at least? I'm not going to worry about that. If you have two equal sides, you're isosceles. And then finally, if all three sides are equal, you are equilateral. Now, there is a theorem that, it doesn't really have an official name, but there is a theorem that says if you're equiangular, you have to be equilateral. That's going to come later on, but those two are like a package deal. If you have three equal sides, you have three equal angles, and vice versa. I don't think that comes into play in this section, but I just want to plant that seed for later on. Alright, so we jump into an example, and I actually jump into a pretty hard example. So before we do example 1, I'm going to actually do an example 0. And I'm going to tweak the notes a little bit. And right up here, I want to do example 0 just to see if you guys know what we're talking about. So I'm going to draw a triangle. The triangle is going to look like this. It's going to have angles of 65 degrees, 65 degrees, that's 130. So what's this one got to be? 50 degrees. And let's just say that it has these tick marks. So tell me right now, what is my first and last name, aka classify me. So look at the angles first. My angles tell me I'm a what, Phillips? Isosceles. And then my sides tell me I'm a, oh wait, that was backwards. It doesn't really matter who comes first, but I think when I ask the question, I'll put isosceles back here. This is based on your sides. Now based on angles, I got 4 choices: acute, obtuse, right, or equiangular. Acute. So this triangle that I drew is called an acute isosceles triangle. So all triangles have two names. And if you're equal, both the two equals are always going to be the same. Now I jump right into a tough one, example 1, and say find the length of each side using the Pythagorean theorem or the distance formula. Classify the triangle below. Your notes actually look a little bit different than mine because I think I put in the Pythagorean theorem and the distance formula. Is that right? Alright, so just know that your notes already have that on there. And my triangle looks funky, so I'm going to just go to the real notes. I think they're chilling right here. Yeah, let's go up. There we go. That matches up with you guys. So I never ever use a distance formula. You know, if you just like punishing yourself and doing a lot of extra work, but this just isn't my style. You can use it, but I'm not gonna. I'm gonna use a squared, b squared, c squared. So I gotta figure out how long these three sides are and then compare them. You can go ahead and run down and see Miss White. Yep. So AB is, well, let's do it. AB is this person right here. So I need to figure out how long he is. I can't count boxes. So what I need to do is I need to draw a right triangle. And I draw a little right triangle out here until they meet up. And now I count how long the legs are. So this leg is 1, 2, 3, 4, 5. And this leg is 1, 2, 3, 4, 5. Alright. So leg squared plus leg squared equals, and I could put C squared. I'm going to actually write AB squared, just because that's what we're looking for, is side AB. And now I crank this out. Now I know, and I think I've talked to you guys about this before, there is a shortcut for this. We learn it, I think, in chapter 7 maybe, 7 or 8. But any triangle that has two sides both with 5, I know that this is going to actually come out to be 5 square root of 2. So I just want to plant that seed right now, that when you have a triangle with two sides that are the same, the hypotenuse is always that number radical 2. But let's just do it old school. So that's 25 plus 25 equals AB squared, which is 50, equals AB squared. And how do I get rid of the squared? I take the square root. Now on this problem, you really don't have to find out that decimal, because I'm just trying to see, is anybody else the square root of 50? You know, if there's 2 of them, if there's 3 of them. But if you want to, you could calculate that out, and it'd be like 7 point something. Like 7.06, it seems like. Jumps into my head. You could check me on that. But so I think he's 7.06, aka square root of 50. And then I'm going to repeat the process. I'm going to go a little bit quicker on these other sides. So I'm going to do the same thing for BC. And BC is a long, skinny triangle. He's a 2 by, what's that, 7? He's a 2 by 7. So to find BC, he is a 2 squared plus 7 squared, which that comes out to be 4 and 49. That's 53. And I take the square root of both sides, and I get the square root of 53. So I kind of sped a couple things up there, but you get the gist of it. So, and I don't know what decimal the square root of 53 is, but I do know that right now they're different. I have a square root of 50 and a square root of 53. So I can rule out equilateral. Even though it kind of looked like it was equilateral, it's not, because they're different. So the final piece, I want to figure out what AC is. Well, AC is going to be right here. And he is a 2, another 2 by 7. So I really don't even have to do the math. They're both 2 by 7s. I'm just going to write the answer down. It's a square root of 53, because I already did the 2 by 7 up above. So now that we know the 3 side lengths, square root of 50, square root of 53, square root of 53, if I'm classifying this by sides, what would he be? He would be an isosceles, because he has 2 equal sides. Now I can't classify the angles because I don't know how many degrees these are. To me it looks like it's acute, but I really can't prove it right now. Ari's trying to be a superstar and get on my video. Alright. One way to fame. So the next one, classify these. Here I just want to know, can you read the tick marks? So I'm going to rewrite these numbers because they're kind of small here in class. So that's a 13, this is a 14, and this was a 20. And then looking at the most important part are my tick marks. So let's first translate tick mark numbers over. So if this has a tick mark of 1, this one is also 13, they match. This 20 should go up here and match and be 20. And I think now we can answer some questions. So triangle EGF. That's this lower triangle down here, EGF. Well, it has two equal sides, so this one is isosceles. I'm just going to shorthand it. DEF, this top one, three different sides. So what was that one called? Scalene. And DFG is the big dog. He is 20 by 20 by this side. We got to add them up, and I believe 13 plus 14. He's 27. So 20, 20, 27. He's also isosceles. So that's just knowing, can you use the tick marks to find out which sides are equal to what. This next one, I got to do some calculating here to get my angles. First thing my eyes draw to is this box. That box means it's how many degrees? 90. So I should be able to calculate this one. If I do 90, subtract 32, I believe that's 58. So I now have the top triangle on lockdown. The bottom triangle, there's two different ways to get it. I could add these two up and subtract from 180 to find him, or I could play the 180 game right here and subtract 68 from 180. I think that's what, 112? So now let's answer some questions. And this one, we're doing by angles. I don't know the side lengths, so we'll do by angles. DFG, that's the big dog. Well, the big dog's got a 90-degree angle in it. So DFG is a right triangle. DEG is the top one. Acute, acute, acute means he's acute. And EFG, I see a big old fat angle sitting right there, bigger than 90, so that would be obtuse. So we classified him by angles, and you had to do a little bit of work to get the angles. All right, last two down at the bottom. We're going to use three previous terms or theorems from chapter 1. I always kind of like these ones. It's kind of like a little puzzle that you just got to work your way across and get what you need. But vertical angles, remember, vertical angles are whenever you have two angles across from each other, they're equal to each other. When they're kitty corner like that, and then these two would also be equal because they're across from each other. Linear pairs, straight lines are 180, and triangles have to have 180. With those three facts, we should be able to crush this. I'm going to just do one of them, and I'm going to let you try to do the other one before class tomorrow. So this one on the left, seeing some things, I see a pair of vertical angles right here, so I'm going to write 85. I don't see how I can get the question mark just yet because I don't have that angle right there. So I'm kind of stuck over on that side. But I look over here on this side, and I got 2 out of 3. So I can find him right there. 85 and 45 is 130. And when I take that away from 180, it looks like there's 50 degrees left over for this triangle. Now here's the toughest part for people. The toughest part for people is using these two right here and right here to jump across into the third triangle. So I'm going to play the straight line game, but with 3 pieces. That's a half a circle or 180 degrees. I have 50 right here. I have 60. So right now I'm at 110. So to get to 180, I subtract those dudes, and I got 70 right here. So that allows me to leap into that triangle, which now I should be able to rock it out and get this answer because I have 70 plus 85. It's a weird looking 7. And that's 155. Subtract from 180. Final answer, 25 degrees. So that's a lot of work. I had to get quite a few different people before I could get that number. So you got to have a little bit of stamina to battle through that. So this one I'm going to leave up to you for tomorrow, and we'll work on our practice in class tomorrow. See you.